Hi, in this video we're going to talk about different functional forms for linear regression, specifically using logged independent and dependent variables. The data I'm going to use for this is a data set from my own work that takes a look at peacekeeping contributions and arms imports from members of the Security Council. So in this case, our dependent variable is going to be a count of the number of troops that a country contributes to a UN peacekeeping mission in a given year. And our independent variable is going to be the value in millions of dollars of the arms imports that a country receives from a permanent member of the UN Security Council. So these are both interval level variables. Accordingly, it's always a good idea with that kind of data to take a look at a scatter plot to get a sense for the relationship in the data. Okay, this scatter plot suggests that there is some sort of relationship and that it might not be exactly linear. We can sort of imagine if we fitted a line to this, it might curve up like this. So this suggests that perhaps a different functional form other than a strict linear line of best fit might be a good idea. So let's take a look at different models that incorporate a log of either the peacekeeping variable or the arms imports variable. First model we're going to look at is a lin log model or a level log model, in which case the independent variable is logged, taking the natural log, and the dependent variable is left as is. So the variable hasn't been transformed yet, so the first step is to generate a log of the P5 imports variable. Okay, so if you'll notice from the code here, I generate a new variable called log imports. I set it equal to the natural log of 1 plus P5 imports. Why do I add 1 plus? Well, if you look at the data viewer and we go to the P5 imports, we see a number of cases where countries haven't received any arms imports from P5 states. That's going to be problematic if we're log transforming our variable because we can't take the natural log of 0. We can, however, take the natural log of 1, which is 0. So I'm going to add 1 to all of every state's P5 imports as a constant and take the natural log. That way, all the 0 observations will maintain as zeros once we do the transformation. If we did not add 1 to the data, the 0 values for the P5 imports variable would show up as missing values in the log transformed variable, which would be problematic because then there would be something systematic about our missing values. So we're going to go ahead. Okay, so now we've transformed the log import, the P5 imports variable into a log imports variable, and we can run our regression. So in this case, remember our dependent variable, peacekeepers, is not going to be changed, but our independent variable, P5 imports, has been transformed into a natural log. Okay, so we see a very big coefficient here, but you shouldn't be sort of completely surprised for that because we interpret the coefficient in a level log model differently. So here, it's not that the effect of a $1 million increase in arms imports is 118 more peacekeepers. What it is actually is that what the coefficient means is that a $1 million increase in a country's arms imports leads to a 1.2% increase in that state's peacekeeping contributions in a given year. More generally, what we do is we take this coefficient, divide it by 100, and that is the percentage increase in Y that we get from a 1 unit increase in X. So again, this tells us that a 1 unit increase in X, in this case a $1 million increase in the country's arms receipts from a P5 state, leads to a 1.18% increase in its peacekeeping contributions in that year. Okay. What about a log lin model or a log level model? In this case, the dependent variable is logged, but the independent variable is left as is. In this case, we need to generate a log of our peacekeeping variable. So here I've used generate a new variable. I've named it log_peace. equals natural log of 1 plus peacekeepers. Again, I added 1 because we can't take the natural log of 0, and there are some zeros for my peacekeeping variable, and I don't want those to show up as missing values. So I'm adding 1 to every observation for the peacekeeping variable as a constant. Okay, so I've generated my log peacekeeping variable. Now I can just do a normal regression as I would, but with my dependent variable logged and the independent variable left as is. So I'm not using the natural log of the independent variable. Okay, the interpretation of the coefficient here is a little different. Here we multiply the coefficient by 100, and that is the percentage change in y we get from a 1 unit increase in x. So in this case, a given country in a year receives $1 million more in arms imports from a P5 state. On average, their peacekeeping contribution will decrease by about 0.15%. So not a very big decrease, and it represents a sign switch from the other model. What about a log-log model? Okay, in this case, we don't need to transform any variables because we already have the log of the peacekeeper variable and the log of the P5 imports variable. So we just do reg All right. The interpretation of the coefficient here is pretty straightforward. Basically, the coefficient tells us the percentage increase in y for a 1% increase in x. So in this case, on average, in a given year, if a country's arms imports from a P5 state increase by 1% in that year, their peacekeeping contribution will increase by about 0.2%. So again, not a very large increase. So this shows us different functional forms we can do with logged independent and dependent variables. One thing you may have noticed is I'm getting different results from these different models. That's because these are very basic models for a very complex phenomenon. As you can imagine, a lot of different things go into a country deciding to contribute peacekeepers to a UN peacekeeping mission. So there's potentially a serious omitted variable bias issue. Another issue is that I haven't lagged my independent variable, so there's a serious endogeneity concern. Because these variables are occurring in the same year in this model, how can I be sure that peacekeeping isn't influencing arms imports or arms imports is influencing peacekeeping? We're going to address both these concerns later in the course, but the objective of this video is just to introduce you to level log, log level, and log log models and how to interpret the coefficients. All right, thank you.